Have you ever walked into a sprawling sports bar or seen footage of one of those high-tech control rooms and just wondered how dozens of 4K screens stay perfectly in sync, like without even a millisecond of lag?
Yeah, it's honestly mind-boggling to look at. But today we are doing a deep dive into the actual commercial tech that makes that happen. We're pulling our insights from a spec sheet for the DVIGear DN-300H DisplayNet transmitter and receiver.
Exactly. Our mission today for you listening is to, strip away that dense AV jargon and uncover the invisible architecture powering those flawless video arrays.
Hmm.
And it really all comes down to defeating the ultimate enemy of live video, which is latency.
Right. The spec sheet makes this pretty bold claim, zero frame latency and zero image artifacts.
Yeah.
And that's while pushing a heavy 4K resolution at 60 frames per second.
But, I mean, how far can we actually push this zero-lag video? Are we talking about just a really long, heavy cable?
Oh no, this is where it gets way beyond traditional cables. It uses dual 10G network interfaces. So on standard C6A cables, you can send this signal up to 100 meters.
Okay, that's pretty far.
But if you switch to single-mode optical fiber, you can push that exact same flawless 4K signal a staggering 30 kilometers.
Wait, hold on.
Yeah, that's 18.6 miles.
Okay, wait. 18 miles. How do you push that much data that far without the video just compressing into a pixelated mess?
Because it completely bypasses traditional video limitations. It uses this architecture called SDVoE, which stands for Software Defined Video over Ethernet. See, traditional HDMI cables force a continuous stream of data down a copper wire.
Right, which obviously creates friction and lag over long distances.
Exactly.
Yeah.
But SDVoE chops that 18 gigabit per second video up into tiny, perfectly timed network data packets, then it fires them across fiber optics at the speed of light.
And just reassembles them on the other side.
Reassembles them instantly. You aren't compressing the video at all. You're basically expanding the pipe itself.
That is wild. But, pushing a single movie 18 miles is one thing. In a real control room, you have dozens of different signals crossing paths constantly.
Oh, absolutely. And that's why this device isn't just a video pipe. It acts like an incredibly advanced traffic cop.
Okay, how so?
Well, instead of just waving cars through, it's managing completely different lanes entirely. So you have a lane for uncompressed 4K video, a lane for your audio, a lane for infrared remote signals,
Wow.
and even a lane for USB HID switching.
USB HID switching, meaning, if you move a mouse in the control room, the cursor moves on a computer 18 miles away instantly.
Precisely. All happening at the exact same time without any signals colliding.
That's incredible.
And because it operates over an Ethernet network rather than a fixed traditional HDMI matrix, it has limitless expandability.
I mean, in the old days, if you bought a 16 by 16 HDMI matrix, you were hard capped at 16 screens, right?
Right, exactly. But here, the size of your routing array is restricted only by the size of the network switch you plug it into.
Wait, I have to stop you there, though, because I'm looking at everything this thing processes. It's routing all that data. It even has built-in video scaling engines.
Yep, it does.
Usually gear that works this hard gets incredibly hot. But the specs say it features silent, fanless operation.
Yeah, that's true.
And it says you can pack 4 of them into a 1U rack space, which is a standard server rack slot, barely 2 inches tall. How is it not melting down if I cram 4 of these into a tiny server rack?
That thermal management is the real secret sauce of this thing. It uses a highly efficient design that supports PoE plus A, which is power over Ethernet.
Oh.
The unit only draws about 13.5 watts. So instead of relying on noisy mechanical fans that, inevitably fail anyway, it manages heat through its heavy-duty steel enclosure.
So the box itself is the cooler.
Exactly. It acts as a giant passive heatsink. That low power draw and efficient heat dissipation are exactly why you can densely pack them together without starting a fire.
That is so smart. So to you listening, the next time you see a flawless video wall stretching across a venue, you'll know exactly what's going on. You'll know about the incredibly dense, zero latency network architecture working invisibly behind the screens.
Yeah, it really redefines what we think of as physical limits. I mean, we are transmitting uncompressed 4K video and instant USB control flawlessly over 18 miles on a standard network backbone.
Which leaves us with a pretty wild thought to end this deep dive on.
Oh, definitely.
Because if we can already do this for commercial video today, what happens when this kind of zero latency tech becomes the backbone for everyday remote physical labor? Or even long-distance robotic surgery?
That's a fascinating point.
Right. If you can completely eliminate the lag over 18 miles, Suddenly, the physical distance between the screen and reality completely disappears. Something for you to chew on today.